Welcome back to the Deep Dive. Today we're looking at a piece of gear that's, well, it's really the unsung hero of a high-end video setup. It's the NTI SE-4K18GB-4RS 4-port HDMI switch.
Right.
And I guess our mission here is to figure out why this seemingly simple box is so critical.
It's basically the traffic cop for all your video signals.
The traffic cop, I like.
Yeah, it takes, up to 4 different HDMI sources. Think a media PC, a Blu-ray player, a game console.
All the good stuff.
Exactly, and it routes them all to one single display. It's really about consolidation, avoiding a mess of monitors.
And it's not picky about the sources, is it? The documentation mentions Windows, Linux, macOS.
And even server operating systems.
Why is that so important in a professional environment, that multi-platform support?
Because you just never know what you'll be plugging in. You could have a custom media server on Linux and then, a standard streaming stick. The switch has to be agnostic. It can't fail on a weird handshake protocol.
Okay, let's unpack that. Because routing these signals flawlessly is a huge claim, especially when you're pushing serious data. We're talking Ultra HD 4K resolutions.
Up to 4096 by 2160 and at 60 hertz.
And that 60 hertz is the holy grail, right? For high motion stuff like gaming or movies.
Absolutely. To get that, you need a ton of bandwidth. We're talking 18 gigabits per second. That's the HDMI 2.0 standard.
And if you don't have that bandwidth,
you drop frames or the resolution tanks, it just won't work.
But it's not just about speed. It's also color. I see specs here like 48-bit deep color and YUV 4.4.4. What is all that alphabet soup?
I mean, that's where the quality really lives. YUV 4.4.4 means the color data is completely uncompressed.
Okay, so like a raw photo file versus a JPEG.
That is the perfect analogy. 4.4.4 is the raw file. If you're a video professional or just someone who hates seeing color banding, that uncompressed signal is what you want.
And of course, there are security strings attached to all this, HDCP 2.2.
Oh, absolutely. The switch has to be the gatekeeper. If it doesn't support HDCP 2.2, your brand new 4K Blu-ray player it won't send the signal. It'll block it.
So it has to be compliant.
It has to. With 2.2 and 1.4 plus HDR3D and CEC, all the modern standards.
So we've got the raw power, the speed.
Yeah.
But a dumb switch isn't enough anymore. How does this thing handle the real world, devices turning on and off?
That's where the intelligence layer comes in.
Yeah.
Beyond the usual controls front panel, IR remote, RS232.
The pro stuff.
Right. It has automation features that are just lifesavers. Take auto scan. If your current input goes dark for more than half a second,
it just dies.
Yeah, it just jumps to the next live source. No more staring at a black screen wondering what happened.
And on the flip side, what about when you plug something new in?
That's called auto jump. You plug in a new device, and it automatically switches to that input. It's just smart. It even skips inactive ports when you're manually suckling through.
What's so interesting to me is that even with all this tech, you're still limited by physics, by the cables.
It is the hard truth of high-speed digital video. It's a lesson a lot of people learn the hard way.
So what are the limits?
If you want that full 4K at 60 hertz, you're looking at a max of 20 feet with a standard passive HDMI cable.
20 feet? That's not very far if you're running to a projector.
It's not. Now, if you drop to 1080p, you can get up to 50 feet. But for 4K over 20 feet,
it's something special.
You need an active HDMI cable. It has a tiny video equalizer built into it that boosts the signal. It's non-negotiable for longer 4K runs.
Good to know. And one quick warning about DVI adapters.
Yeah, if you're using DVI adapters for a source or display, just remember, DVI does not support these high-end 4K resolutions.
So to sum it up, what you're getting here is an intelligent, robust solution. TAA-compliant 2-year warranty. Basically, it manages 4 high-bandwidth streams without breaking a sweat.
That's the takeaway. It just works.
But here's the thought I want to leave everyone with. If a simple 4-port switch needs all this intelligence, like autoscan, and it forces us to use special equalized cables just to push a perfect 4K signal 30 feet, what incredibly complex processes must be happening inside that little box at the silicon level to make sure that 18 gigabits of data get through every single second flawlessly? Something to think about.